All right, thanks for the introduction again, Gitika. My name is Hitath, and today we're going to talk about the basics of networking on AWS. So before we start off, I just want to know how many people come from a traditional networking background. So a few of you guys. And how many people know about AWS or have kind of used it or just know about it? Okay, most of us, so we're in the right room. No Azure or AWS or Google Cloud today. Mostly AWS talks, but the point being, the cloud space is very similar concepts-wise. So what you learn here can be translated to different clouds in the long term. It's just different languages or different terminologies. And with this talk, I want to make you guys comfortable enough to understand how the terminology works in AWS, how the network looks like, and how you can probably create and look at your own network once you go home and create an AWS account. So about me, a little bit about me. My name's Hitath, like I said. Same name on LinkedIn if you guys want to add me later. That's an old picture. I've been at 11 for almost 2 years as an AWS Cloud DevOps engineer. We do different kind of stuff for different clients, and we're part of the Spark business group. So we also do some stuff with the rest of Spark businesses, rest of the Spark businesses. And I've got 6 AWS certs, but that's mostly because I work in consulting and the certs make a difference. So if you're looking at certifications later, you can have a chat with me outside, and happy to introduce you to how to prepare for certs and stuff like that as well. So today we're going to talk about networking, and I want you to think of networking like a box. But throughout the talk, we'll think of it like a house. Think of it like a house or a box. Cat in the box, because boxes and cats. And so in a house, when you think about a house, you have a door for security. You enter the house, you've got different rooms, you've got pipes for water, you've got your electricity lines, and you've got your network routers and internet connectivity, because that's a necessity nowadays. I spent a month without internet, fiber internet, and it was terrible. So let's see what we have in a house again. Door, rooms, windows. You've got your wiring for wiring and electricity, which kind of measures and sees what you have around the house and connects electricity to the rest of your house. And you have water pipes and so on. And we'll translate this to different things on the network side without getting too technical. Meanwhile, on the cloud network, your house or box is basically a VPC, also called a virtual private cloud. So it's an empty box, or like a new house of whatever size you want it to be. It could be a one-bedroom house, a studio, or it could be a massive mansion if that's how much space you need. And you can divide your house into different rooms. The rooms are subnets. Subnets are basically you dividing your VPC into smaller parts for different use cases. Something like one for publicly facing websites or publicly facing systems. Other ones for your databases, or something else for a private application that's running in somewhere else. So those are like different rooms in your house. Then you have route tables. We'll get into the finer details about a route table later, but think of them like the mains for your, in your house, where you can turn on and turn off the switches for certain rooms. So your electricity mains control, how many of you guys have seen like the mains control for your electricity? You've got switches for each different room. You can they'll turn off if you're about to have a short circuit in one of the rooms. So that basically controls electricity to different rooms. In this case, route tables control the network flow to different parts or different subnets, like I mentioned earlier. So route tables like the mains. Now we have internet or NAT gateways, which are kind of like your router. They allow you to connect to the internet. So those two are used for two different use cases, internet or NAT gateway, but all they do is they allow you to connect to the internet because it's essential. Then you've got firewalls, NACLs, security groups, and well, those three, which I find are like doors. They allow you to access or stop access to and from different places. And then we have gateways and endpoints, which are like a window. They allow you to connect to different parts of the rest of AWS or certain other AWS services directly without going through the internet. So I couldn't find any other thing for that, but to me it seems like a window. I can just open and look outside and see how things are without, in this case, without the gas coming back in. So let's think about, let's go through this again. The VPC is like a room, different sizes. VPC is like a house or a box with different sizes. In your house, you've got different rooms, which are like subnets. And then you've got route tables, which are the mains or the power supply spots in your house. You've got internet or NAT gateways, which is the internet connectivity for your house. You've got firewalls, security groups, NACLs, which are like the doors, allow you to access and stop access to different spots, and gateways and endpoints like windows. So the first one, VPCs, in detail. VPCs are called virtual private clouds, and they're logically isolated virtual networks in the cloud. It's just a fancy name for like having a kind of traditional network on a certain cloud. So you can define how big or small you want your VPC to be. For the time, if you're not too familiar with the CIDR notations and subnets and IP addresses, don't worry about it. Just stick to whatever you get by default. Something like 172.17.0.0/16. That's kind of how big your VPC would be, and that can be divided into the smaller subnets or smaller rooms. So things you should know is, I read this, this one's actually new for me, is some AWS services actually use that 172.17 range. So if your IT team decides to use that, you might want to stay away from it because it might clash with other AWS services. There's 5 VPCs in the region, which is soft capped. You can ask for more. And then CIDR ranges for AWS start from /16 and go to /28. That's based on the limits for AWS. So that would be an example. CIDR range over there is 10.0.0.0/16. It has lots of IPs. I don't know how many, just lots. Trust me on that for now. And we can search it up later and see the exact number. So you've got your VPC now, 10.0.0.0/16. There's a tiny picture there. It's not too clear, but you can see it looks like a box, which is why I said earlier, think of it like a box, because in all the diagrams that your architects will send you, it'll look like a box. Then you divide your VPC into smaller rooms. Those are your subnets. They can be public, private, VPN only, or isolated. The rule of thumb is public subnets are for anything that's public facing. Private subnets is anything you don't want to have in the public subnet. So a web application would live, say, in the public subnet. Your database would live in a private subnet. And VPN-only subnets connect only to your VPN. They do not connect to the internet. And isolated subnets are completely isolated. No internet connection, no public connection. Private subnets, in that case, also have outward connectivity to the internet, so that's something to keep in mind. All it means is you can look outside, and you can ask for stuff, but you can't have someone come in from the outside. So each subnet must be in one availability zone. For AWS specifically, availability zones are kind of like separate data centers in the same region. So you'll have, most of the time you'll have 3 AZs. For Sydney, it's the region itself is called AP Southeast 2, and you've got AP Southeast 2A, AP Southeast 2B, and 2C, which are 3 availability zones all in Sydney, kind of slightly away from each other. So for high availability purposes or DR purposes, each subnet should be in a different availability zone. In that case, when you run something a little more focused on DR or high availability, you have an instance running here, or an instance running here, and an instance running here, or one virtual machine running in each of these subnets over here. So one subnet, one availability zone. And the route tables, the fun part, if you like networking. Let's all admit it's not the most fun thing. I'm trying my best here. But each subnet is associated to a route table, which tells the subnet what routes it can access internally. And we'll jump to route tables in a second. Does anyone have any questions or anything they're not too sure about so far?
So you mentioned that subnets can be public, private, VPN only, or isolated.
Yep.
Can you give us an example on why are you to have the isolated one? A use case for that?
You don't want any internet connectivity that's going outside, and you don't want any other connectivity. So if you want to run something completely isolated from anywhere else, that's the only use case. I've not really had anything in that use case personally. It's just something I saw online from like the documentation on AWS, and it's a fun thing to know because it's technically like a private subnet, but just no internet connectivity.
What you asked, so in terms of isolated network, so we have something like the Azure backdoor network.
Yep.
So it doesn't go with services unit, it's like Microsoft Azure set up a backdoor network. I mean, in fact, specifically for that isolated network when you're working in Azure Cloud. So is something similar AWS has?
You have AWS Private Link, which connects to the rest of the AWS services, and you have the interface and gateway endpoints that you can have within your within that subnet.
Do you need to have those endpoints for isolated network?
If you need to connect to certain services internally, you could have them. You don't explicitly need them by default. It really depends on the different use cases. So if you want to just have a completely isolated VM in this, say in this subnet, without anything on there, without any internet access, without anything else connecting to it, you wouldn't need private link. But if you want to connect to, say, DynamoDB or S3 for storage, then you could have your gateway endpoints or your interface endpoints there.
What is the difference between private and isolated?
So private subnets can still access the internet outwards. So if you have outgoing access is still allowed for a private subnet. An isolated subnet, again, it's just a private subnet but has no outgoing access. It doesn't have any VPN access. It has absolutely no access to the internet over there. It only has access to the rest of the VPC, maybe. Yep.
Just if someone's going through that process to do it, would you think it'd be a good idea, and if AWS allows it, for like public, private, VPN, isolated, like one's in the 10 network, one of those is in the 192 network, one of those is in the 172, just so that you don't accidentally mix things up, but you can still, you know, move things around?
Yep, you could have that. So general rule of thumb with VPCs is you don't, I'll go back to that slide here. You've got these different side ranges and you don't want them to clash with any other networks. It's like saying I have a house and then my friend has the exact same house. That's not possible. So you could have that, and that's probably a good design choice to have. If you want a VPN-only subnet, have it in a different CIDR range or different address space.
Yeah, well, like you've got the three prefixes, you've got the old, you've got 10, 172, and 196, like one's public, one's private, and
Yep.
ideally you'll never accidentally get what generally causes problems, right? Someone forgets, and next thing you know, you're buying your own account. But
Yep.
I guess completely.
So that would be one way to do things. Another way I've seen how people have done things is have their on-premise network on the 172 or 192 range, and then use the 10.x range specifically for AWS, and then have different sizes of VPCs based on what use cases they need there.
One question. Can we have redundancy within two AZs from two different regions?
Two different regions and two AZs. That would be more multi-region, so that would be...
Is it allowed?
In what sense? You can still have it, you just have to design your application to run that way. You can still connect your networks. I haven't done multi-region connections, I know it's possible. It's just slightly different. But they are supported. So, you've got your VPC, you've got your rooms, your subnets. Now you have the route tables. Sorry, there you go. The mains to your electricity. Route tables kind of look like this. Slightly blurry image here, unfortunately. But on the left you've got a destination, and on the right you've got a target. It's kind of like a phone book. And they contain a set of rules that includes or determines where traffic can go, so what the address space is and where does that address space lie. For anyone who doesn't know too much of networking, what you need to know is, in this case, it says 10.0.0.0/16, which is that VPC. It's local. It's your house, so you can go to other rooms in your house. 0.0.0.0 means everywhere. That means you can go outside of your house and maybe to the countdown or something like that. Now, a local route table is present by default when you create a VPC. You've got a main route table that kind of has this local address so that you can go around the whole VPC. But you can also have custom route tables, and what people end up doing is they have different custom route tables for different subnets. So a public subnet will have that 0.0 IP 0.0.0.0 route, whereas maybe a private one, if they don't want that, they won't have that route to the internet. They'll probably have a different route to a different subnet or a different VPC. And yeah, so destination and targets. Destination is what range of IP address it is, or back to that whole big bunch of numbers with dots, that's stupid. Where does that go? That's all I want to know. Does that go to another VPC? Does that go to those internet gateway things I mentioned? Does that go to a set instance or an IP address? It can go to different targets, which are, yeah, they can be different AWS resources. So your address book is defined. Now you know where you can go. But let's say I don't have anything for the internet. So now we have internet gateways for internet connectivities. And NAT gateways, fancy term for private internet gateway. That's how I say it, but it's basically for, so internet gateways allow your public subnets to go to the internet. Like I kind of hinted, the NAT gateways do the same thing. Internet, but for your private subnets. So the NAT gateways live in your public subnets, if I'm not mistaken, and they allow your private instances or private resources outbound access to access the internet and pull, say, Python or any other dependencies that they want to pull. Both of these are managed by AWS, so they're both highly available, horizontally scaled and redundant. Fancy cloud terms for I don't need to worry too much about managing this. And NAT gateways, surprisingly, can be, again, public or private. public means they route to the public. Private means they route to your on-premises VPC. So if you want to have that on-premises routing, you could have a private NAT gateway. I've personally haven't used them so far in a private sense. Most of the time I've built one, it's to connect to the internet. So I would stick to having so-called public NAT gateway most of the time. And you've got your doors that are your firewalls, knuckles, security groups. We're almost close to the end of the whole slide deck. It's not too much, but it's a lot of information for someone who hasn't heard these terms. So the doors, they allow you to enter, exit different rooms. They've got fancy names again. Why does everything have to be so fancy? But they're all kind of similar doors. One's like a very big door for your whole house. One's like for a certain room. One's like a smoke or like a blind. So firewalls, normal firewalls, you can define them by yourself using other AWS network firewalls, something else. But more importantly, NACLs that are called network ACLs. ACLs stand for access control lists, a list defining who's allowed in and out. So network ACLs operate on the whole room on your subnet, and security groups operate on your instances or specific resources. They kind of do the same thing, but general rule of thumb is security groups allow, sorry, I need to check that again. Yep, security groups are used to allow traffic. NACLs are used by default to block traffic. So in a security group, you'd have something like allow my instance to SSH or to access port 80 for my web application. So allow anyone to access port 80 on my web application and allow my instance to go out to the internet. Those would be some kind of the rules you'd have on a security group. I'll show you that on the live demo. I don't have it here. And NACLs are used by default to block everything that's coming from this IP list or this malicious IP address that was DDoSing us a couple of days ago. Let's block this. So any routes to and from by default are blocked on NACLs, and security groups are used for allowing. That's all you need to know. It's like push and pull.
Sorry, what does this mean? STs track the state of a connection?
Yep. So that part is network ACLs are stateless. They do not track a state of your connection, whereas security groups track the state of your connection. So if you're allowed if you're allowing port 80 inbound, it'll automatically allow port 80 to go out as well, something like that.
Is this the state? This is what the state is called, right? That it's port 80, what is happening to port 80?
Yep. So that's security groups are stateful. That means they track what connections are allowed inside, what connections are allowed outside. So if you have, like I said earlier, if you have a connection incoming on port 80 or incoming from one place, and you want to go out back to that same connection, that's allowed by default. So that's what security groups kind of do and what NACLs do. And firewalls can be added, they're not added by default, but they're definitely present. So I think last part before I name drop some of the more advanced stuff if you guys are feeling up to it, but gateways and endpoints, the windows. You've got two types of endpoints, gateway and interface endpoints, and they're basically used in private subnets to connect to different AWS services. If you want to connect to S3 or DynamoDB, you use gateway endpoints because that's kind of what they were made for. Otherwise, you use interface endpoints for something else to connect to other services that use AWS Private Link, which is not over the internet and over the AWS network. So if I want to access stuff that is not over the internet and still over the AWS network, I would use gateways and endpoints, which would connect to private subnets. The advanced stuff, I'm going to skip that for now unless you guys feel up to it. Who feels up to the advanced stuff? One person? Too much? Two people? Right, let's name drop it quickly. You've got peering connections, connecting, well, instead of boxes and houses, we'll use chairs this time. This chair is one VPC, that's the other one. I'm going to connect them together. I use peering connections. That's called VPC peering. Transit gateways act as a hub. I'm in the middle. I'm holding these two together. I'm the hub allowing this to go there. That's a transit gateway. Transit gateways connect to multiple VPCs together in the same region. They can be used in a different region as well. They have ways to do things in connect different regions together. Flow logs capture information about what's happening in your VPC, what kind of IPs are coming inside and outside. So if you want to see who's coming inside and outside your house, you have like a Ring door camera that's kind of like a flow log that would check everything and put it into some kind of storage for you to see. You can also do traffic mirroring, which is just mirroring the same traffic that's coming to one part of your network so that you can run it through a security application and see how things go. You've got VPNs, I've mentioned that a bunch of times, is connecting your on-prem to AWS, which is kind of over the internet. And you've got Direct Connect, which is a dedicated connection from your on-prem servers to AWS with dedicated bandwidth. So there's these bunch of advanced stuff. As you can see, there's a lot that's happening with networking. But for now, we should focus on the small parts. VPCs, like a box. Subnets, different rooms in a box. Route tables, internet gateways, and run something in your VPC or your subnets. So, live demo time, unless people have certain questions they want answered right away. No questions? Cool. I'll grab a seat for this one. So in the live demo, I have to sign in again. Okay. In the live demo, I have a VPC that I've created by default previously, and I've also got the option to create one. First, we'll create a new one just to show you how things have improved over time on the AWS side of things, and then we can probably go through the new one or the old VPC that I created. So when I go on the AWS console, I'll just go back there again. You can, sometimes things might show up here if you've used them before. If not, you can click over here, search for VPC, isolated cloud resources, cool. I want a new house or a new VPC. You can see I have two of them over here. I've got some other things over here. Well, it says, oh, NAT gateways, right? You guys know what that's used for? Anyone?
To connect a private subnet to the internet?
Two people with chocolates. Oops. Oh, missed the table. You need another one. Or is that? I'll leave that for the next one. So you can see all of these different things that I mentioned earlier. We've got subnets, peering connections, advanced stuff, but route tables, network ACLs, internet gateways, all of that. Don't worry about all of this. Most of the time it will be on 0 or 1. I forgot to mention this earlier. By default, you'll always have a VPC in each region. So you could potentially use that, or you could just snoop around through it now that you know how the language works. So your VPCs, I want to create a new one. I've got two of them here, and I've got these two CIDR ranges, 172.31 and 10.0/16. If you've got existing stuff, make sure it doesn't clash with anything that you're creating, right? So if these are on-premises networks, I wouldn't want them to clash, because once I have a network clash, it's gonna make my whole IT team go a little bit mad, but like, oh, that's clashing now, we can't do this. So create a VPC. You've got two options here, which is a lot better than how compared to what it used to be, is I'll go to VPC and more, and I can just auto-generate most of it right now. Or I could manually just create the VPC. So this time I'll go to auto generation because it's a lot more faster. And I'll say, I'll put this as live demo. And, well, no clashes. What do? I'll do a 192.1. There you go. Remember how I told you, trust me, there's a lot of IP addresses available in that. 65,536 seems like a good chunk to me at this point. As networks grow, you need more space, which is why we have IPv6. Speaking of which, I forgot to mention something very important at the start of the talk. We're not doing IPv6 today, we're doing IPv4, which is most of the time what everyone sees is these things with one dot. If there's two dots in the middle, or if it looks a bit crazy with letters in there, that's IPv6. It just means there's more addresses than 65,000 because everyone has 5 devices now instead of 1. So we need millions of more IP ranges. So no IPv6. I've got this CIDR block. Tenancy, default, dedicated would probably be for dedicated. Fun fact, if you don't know anything, like I don't know about this tenancy thing, I click on information here. Default to ensure that instances use the tenancy attribute specified at launch. Okay. Dedicated to ensure that instances in this VPC are run on dedicated tenancy instances regardless of what's specified. So I don't want that to happen. That's kind of like an override. Now, number of availability zones. If I need 1, I can select 1. If I need 2, I can select 2. If I need 3, I can select 3 of them. Again, you don't know anything. It's okay. Just look at the information here or read up. Documentation's a developer's best friend, and get used to some of the documentation. It's not that bad. You can read up and spend a couple of hours reading up if you need to, or just follow a tutorial sometimes as well. You've not seen how many tabs I closed and how many of them were like AWS documentation tabs, so trust me, it's okay reading up on all of this stuff. So, number of public subnets, 0 or 2. Number of private subnets, 0 or 2. I'm going to keep, or 4. I'm going to keep both of them to 2 each. I can customize the subnets of my CIDR block, but if you don't know too much about this, leave it to AWS for now and read up on it later when you feel you're prepared to take up more of that. I don't know all of it. Most of the time I look it up on Google. Look, I'm not said I just Google most of my stuff and ChatGPT nowadays, because yeah. So I'm not the most comfortable with IP addressing and all of this, and it's okay. You can search it up. There's a lot of tools online to help you. There's stuff like IP subnet calculators, and that would allow you to like calculate subnet and IP stuff. Admittedly, they kind of look boring, which is why people don't like networking enough. But look, this is more exciting. So NAT gateways. Another one. There's a $sign there. You pay for that. So that is going to charge you something. I haven't checked the pricing at this point, but you can read up on that, but beware of anything that puts $1 or says is chargeable on there. That means they will charge you for it. And VPC endpoints. So if I want to access S3, it'll create the endpoint for me. Enable DNS host names and resolution. Keep them ticked. You can read up on it later over here. I don't want to make things too technical. I just want you to be comfortable using a VPC and looking around most of it right now. Additional tags, if you want to tag your resources, which is a good practice, because then if something starts charging you like $100 or $200 a day, you can see what is charging you that much money. So I don't need a tag at this point, so I'm just going to create it. Oh, no, remove that. Create it. Now, because of this new fancy thing that does everything for us, you can just see all of these things over here. All of these resources are created. You've got your VPC, you've got your connection to your VPC, you've got your endpoints, your subnets, your internet gateways created, your route tables created, it's associated, it's created IPs for you. Elastic IP just means it's an IP address that's used for a NAT gateway. So NAT gateways use IPs under the hood, and all of it's done. We'll wait a few minutes, and by the time this thing goes on, I will open the previously created VPC. And another 5 minutes and a few more questions that I mentioned. Okay, what's the first thing you want to see in a VPC? Anyone want to see? Decider range of your VPC. So click on the test VPC. CIDRs tells you your CIDR range, and associated means it's working fine. Another new thing that was added is called a resource map. Over here, let me see if I can expand that a bit. This one shows me my VPC. I'll move that. And you can see over here, I've got my subnets. I've got my subnets over here. 2 subnets in AP Southeast 2A. One is public, one is private. 2 subnets in AP Southeast 2B, the other availability zone. Again, one is private, and one is public, and one is private. If I go here, you can see route tables and which one is associated to which route table. So test subnet public 1 is going to test route table public, and you can see test route table public is also going to the other public route table. So if I open that in a new tab, what am I going to see here in the route table? Anyone?
The routes.
Yeah.
Ports.
What's the other one?
Ports.
Not ports.
Allow or deny.
Not allow and deny.
Destinations.
Making the
Destinations.
targets.
Target and destinations. Routes was also correct, so I'll give you that one. Again, oops, sorry. I'm not the best at throwing things from here. Oh, not my day. I've spent a lot of time for that. Who got the last one?
That was me.
Destinations. Pass it on. So, you've got routes, you've got destinations and targets. I'm hoping no one saw that earlier, but you've got everything going to your internet gateway over here, and this going locally allowing your VPC to access stuff. Couple of more minutes, and if I go to the private one, instead of an internet gateway, what will I see over there?
NAT.
Yep. You want another chocolate? Who wants to take the NAT gateway chocolate? But yeah, there you go. I manually changed that one to route everything in the internet to the NAT gateway. I've got another destination there, you can see that says VPCE. If I click on it, it goes to my endpoint over here. So anything that's in blue like this is going to be a link to somewhere else. Feel free to click around and see how things go. But you've got most of your stuff over here. You've got your VPC, subnets, route tables, internet gateways, you can see them again. You've got the live demo one here that's created earlier. Egress only internet gateways, don't worry about those. All of these other things, don't worry about them. Maybe elastic IPs if you need an IP address. Most of the time AWS will create them for you, and endpoints would be something you might want to create by yourself. I'll just show you this one quickly. There's a lot of different endpoints for different AWS services. You can see these over here. So there's some for SageMaker, there's some for like RDS, which is the database service, if you've got relational databases. If you've got stuff like EC2 messages or EC2 or SSM, which is used for jumping into your box without actually managing keys and stuff.
It's already set.
Yep, you have to just select the service you want and select what VPC it would be in. So say that one. I'll select this one. I'll say I want it in my test VPC, in the subnets with whatever security group. That's something I didn't show you earlier, so I'll show you that one right now. And if I need access customized, I can look at that, which I don't need. I can create that later. I didn't put a subnet dash over there. A subnet over there. Didn't select my subnet. So I'll put them in the private subnets over here, and I'll create them. Create the endpoint, and that creates an endpoint for me. Last one, I think so, security groups, is we've got inbound rules over here where I can have anything for SSH on port 22, like so. I can edit that, and I can have something like port range 80. Look for more info if you need more information on those. Source type, I can set that as my IP, a custom IP address, or anywhere IPv4 or IPv6. So if I put my IP, it'll pull my IP address and add that there. It says, and a description, allow my IP access to this security group. So any resources that have this security group now will be able to, I can access any resource that's using this security group on port 80. Save it and it's done. Same thing for outbound. You can edit it by default. Everything for outbound's open. You can add a new one over here that says, let's say I only want UDP traffic or TCP traffic on, instead of port 80, I'll do 3389. It's Windows stuff for the Windows people. And I'll say custom IP address, and I can put a custom IP address here, or I can connect that to a different security group, or a prefix list, or some other resources. So there's, like I said, there's a lot that adds on to the networking part as we go along, but it's very simple to start and to start building your own network and using it for deploying different resources. We're going slightly over time, so I'll stop here if we have any questions, and got some more chocolates if people want chocolates, or they're happy to take a quiz, bunch of questions that I prepared earlier. But yeah, that's it.
One question.
Thank you. Question?
Earlier on you mentioned like there's like internet gateways and then there's like NAT gateways.
Yeah.
Is that implying that the internet gateway is the resource that sits behind those have internet reliable addresses and don't require NAT, or it's just a term between like public groups and private groups with a NAT?
It's kind of just a term, internet gateways. So what happens is your NAT gateway sits in the public subnet and it connects to the internet gateway,
Yep.
which then allows you to connect to the internet. But there's probably more to it. For now, I'm just going to say just terminology, because under the hood, they're probably using similar stuff, but have different access or are made specifically for, NAT is specifically made for like private subnets.
Yep.
Any other questions?
So do these private NAT gateways also traverses the internet? Or
Yep.
okay.
So NAT gateways are used so that you can traverse the internet from a private, or to allow any private resource to access the internet outbound. That's kind of why you'd use a NAT gateway. No questions? Cool. I forgot another thing. Before we close up, just two things. You can connect with me on LinkedIn and feel free to ask questions or the slides if you need them. And the other one was just a quick shout out to the AWS Community Day.
Yes.
I was going to do a Kahoot, but it turns out you have to pay for that, which I'm not doing. So, questions? AWS Community Day Wellington, Susanna, on the floor.
Yes. So thank you so much, everyone. It was fantastic. Thank you so much.